Section 4-5, we're going to look at other trigonometric functions. Specifically, we'll start with tangent, and we're going to see a lot of different things as we move on. Now, tangents looks a lot different than the sine and cosine waves. Remember, those were waves in 4-4. Today, we're going to look at the other ones, and they're not waves. So tangent is like this. It looks like cubic functions recurring over and over. Well, they have asymptotes in here. Now, remember, tangent is y over x. That was what we talked about. Tangent is y over x. Psi y cos x, tangent is y over x. And if you think about it, if psi is y, that is the same thing as saying sine divided by x was psi y cos x. Sine divided by cosine. Now this is exactly the same thing as tangent, sine divided by cosine. There are times on this cosine curve where it hit 0. And so there's times when you'd be dividing by 0. That would be where these come from. Remember, in mathematics, you're never allowed to divide by 0. So when does cosine equal 0? Well, cosine equals 0 at every one of these asymptotes, at pi over 2, at 3 pi over 2, etc., etc. Every odd pi over 2. So if we go this way, negative pi over 2, negative 3 pi over 2, negative 5 pi over 2 would be the same thing. So that's where you get these asymptotes here, by dividing by 0. Here's some properties that I'm sure you can just look down on your paper at. All right, and so the period of a tangent function, if you didn't see it, the period is the time for one whole cycle. They are, if you look here, this occurs 1 pi apart from each other. So they occur every single pi. Or you can go here, maybe it's easier, from 0, where we hit the origin. The next time we hit the origin is at pi. So it's a period of pi is the length. Remember, this is amplitude. The b could be used to find two different things. It could be used to find, well, technically 3. We could say the frequency, and not only the frequency, the period. So period was first, so I'll write that first. Period and frequency is what we could use to find that. The b and the c together we use to find the phase shift. Whoops, that's not how you spell that. There it is, phase shift. And finally, if there's anything on the outside, that would be a vertical translation, if it had a plus d on the outside. All right, so same thing with a period though, but instead of saying 2 pi over b, notice the change. Today with tangent, a period is pi over the absolute value of b. All right, so here's a picture. It's already graphed for you here. It says locate the asymptotes and sketch the graph of y equals tangent x over 3. Now we could rewrite this as y equals tangent of, this is the same thing as 1/3 x, which means my b is 1/3. My amplitude is 1. That's be here, so that would be the amplitude. There's no vertical stretch, if you will. So the b is 3. So if I wanted to find my period, the way I would do so is I would take pi and divide it by 1/3. Now remember, when we divide a fraction, that's the same thing as saying the numerator multiplied times the reciprocal of the denominator. So it would be 3 pi. So if we look at this point, ratio from here to here would be a distance of 3 pi. Or if you started counting from here over to here, that's 3 pi. This is negative 1.5 pi. This is positive 1.5 pi. The distance between those two is 3 pi. And remember, if we need to find the frequency, you would just flip it. So if the period is 3 pi, and I should have boxed this up so we can see it easier. If the period is 3 pi, the frequency is equal to 1 over 3 pi. That means to go one cycle, you have to travel 3 pi. If you reduced it, you would find out how many cycles it makes per 1 unit. And it would actually be less than. It'd almost be about 10% of a cycle every 1 unit you go to the right. Let me make sure I didn't miss anything else. It says locate the vertical asymptotes and sketch the graph. Okay, so vertical asymptotes. We have to find out when we have 0 in the denominator. All right, so 1/3 tangent x is the same thing. Again, tangent is like sine over cosine. So you're looking at when cosine would be equal to 0. And so tangent 1/3 x is the same thing as sine 1/3 x over cosine 1/3 x. And basically what you want to know is when is that equal to 0? And that's how you would solve for the asymptotes. You would ask yourself the question, when is cosine 1/3 x equal to 0? That's what you would solve for here. And now the way to solve this, the easiest way, is we could take the inverse. Remember, if we do the inverse, it switches these two, because I don't know what x equals. So I could actually say the cosine inverse of 0 is going to equal 1/3 x. And to get x by itself, I would just multiply both sides by 3. If I type this in the calculator, those would go away. Let's see what we get here. So I'm going to go to my calculator, and I'm going to do 3 times the cosine inverse of 0. I hit enter, and it gives us this value. Now you need to check something to know if you're in what type of mode we are in. And so I think if you go up here and hit this, it'll tell you right now we're in radians. And that's what we need to be in, because that's what these are. They're radians. If you needed degrees, you'd go to the home screen, hit settings, choose document settings, and change it there. But this is what we wanted to be in, was radians. Now, what is that in terms of pi? The way you do this is you would divide it by pi. And in terms of pi, this is 1.5, which means that x is equal to 1.5 pi is equal to x. That's what the asymptote occurs. And since we know that tangent goes through the origin, it's what we call odd here. If it goes this way to 1.5 has an asymptote, it would do the same thing going left, 1.5. And then you could calculate, oh, there's a difference of 3 pi, so the next one would occur 3 pi later. Or you could look at this period that we already found. If one occurs at 1.5 pi, then the next would occur every period. So you just keep adding 3.5 to that. Now, here's one for you to try. So again, the way to do this is you're going to try to figure out where is cosine for x, because tangent is y over x, or sine over cosine. Where is cosine of 4x equals 0? That's the question you're going to ask yourself as you try to solve this.